Hello, greetings of the day to my respected professors. I'm Raichura, having the student ID 77352346. Here I'm to deliver a presentation on the topic and investigation of integration challenges posed by renewable energy systems in smart grids. The first page shows the poster presented, and this includes overview, aim and objectives, rationale, literature review, methodology used, research outcomes and discussions, conclusions, ethical considerations, and finally the references. Each and every uh, topic mentioned above will be explained further. Starting with the overview, the conventional method used in power generation, transmission, distribution, and its utilization is explained. The need of smart grids is discussed, explaining the further transformation of from conventional methods into smart grids, its significance, scope, and benefits of smart grids. It uses a Simulink model to explain the integration of renewable energy resources in smart grids, where a model is constructed in MATLAB and simulation is carried out by considering a various electrical parameters. The results are represented in waveforms and bar charts. The aim and objectives. The aim is to of this dissertation is to investigate the integration challenges posed by renewable energy resources in smart grids. The objectives are: first, to understand the role of renewable energy in smart grids; second, to evaluate the challenges presented by the integration of renewable energy resources into the smart grids; and finally, third, to design and simulate a model in MATLAB and investigate the integration challenges caused by renewable energy resources in smart grids. The rationale of this research paper is the incorporation of renewable energy resources in smart grids is essential aspect as it would help in getting the resilient and sustainable energy solutions. The rationale behind this research paper is rooted to imperative effective study addresses energy scarcity on the global level and the simultaneous pursuit of environmental sustainability, energy securities, and economic viability. The distribution and transmission of grids need to be updated in order to increase the dependability, economy, security, and efficiency. The, the traditional grid is being transformed by smart metering, quicker problem diagnosis, and enhance the network operation and administration. Additionally, the challenges of cybersecurity has become largest as the smart grids are heavily dependent on digital technologies for control and monitoring purposes. This research aims to unravel the barriers designing by designing a model based on simulation in MATLAB. The literature review in this section, it explores the introduction to the smart grid, describing its characteristics. The predominant components also follows with distributed generators, reliability assessment of the distributed generation in modern grids, and demand response for stable power supply in the system. Additionally, the digitalization of smart grids explaining the communication responsibilities in the power grid for both communication and safety signals in within the switchgears for protection. The benefits of the smart grids are illuminated, describing the real-time measurements and self-healing, increasing the efficiency and interactive uh, between the switchgears, the security, reliability, and optimization, also the distributed generation and market empowerment, and the prosumers. The main attribute of this research paper is to demonstrate the investigation challenges on the challenges of the renewable energy in smart grids. Uh, this follows with the methodology. As you can see, there is a Simulink model designed, and this design is divided in two sections. The first is renewable energy generation, which consists of a PV array generating the output voltage of 1130 volts and the current of 3090 amps uh, by the solar cells. This generated voltage is boosted with the help of booster circuit. The booster circuit also has a function for the protection of the circuit from sudden change of voltage level generated by solar panels. Further, the inverter circuit, which converts DC power to pulsating AC with the help of PWM circuit. The inverter circuit is further connected to the RLC filter for converting the pulsating AC into its sinusoidal form, and also for its modulation. The output is measured by measuring circuit, and scope attached also shows the value of the voltage and its waveform. Finally, the circuit breaker is installed in the line to integrate the power generated from renewable energy resources into the grid network. The second section, as shown in the diagram of the grid topology, is the grid network. This consists of generation unit, transmission unit, and the utilization unit. First, the generation unit consists of three generators, that is A, B, and C, where A is the main generator with the output rated voltage of 6600 volts. Generator B is an auxiliary generator with the output rated voltage of 3300 volts. Uh, this generator B has a step-up transformer installed with it to step up the line voltage generated by generator B to maintain the grid line voltage. The generator C is a spare generator for emergency situations and has the same capacity as of generator B, which is 3300 volts. After the generation unit comes the transmission unit, where the generated voltage is transmitted by a 100-kilometer line uh, with a step-up transformation from 6600 volts to 11,000 volts. This step-up also reduces the power losses in the transmission. Further, it has a step-down transformer of rating 11,000 volts to 6,600 volts, uh, coming which again comes back to the line voltage. Now the utilization unit comes into play, where the power generated and transmitted is finally provided to the consumers for its utilization. This consists of a distribution transformer, which is a step-down transformer, and this steps down the voltage from 6600 volts to 1100 volts for the consumption. This 1100 volts line is directly supplied to the high voltage industrial consumers, and also uh, it's distributed further by stepping down the voltage from 1100 volts to 440 volts for the domestic purposes. Now, considering a different scenarios to supply the power system into the grid, where the different generators are operated with the renewable energy resources integrated into the system. This allows me to discuss the research outcomes and discussions, as you can see on the screen, where the waveform of the output voltages as shown are shown of generator A, industrial load, and the domestic load. The output voltages before the integration uh, is shown on the left hand side, and the output voltage waveforms after the integration of the renewable energy resources into smart grids are shown on the right hand side. As seen, there is no change or disturbance shown in the output voltages of the waveforms, and thus the integration is successfully achieved. Moreover, the bar chart is also illustrates the values of output voltages of generators running before the integration, and also find the values of output voltages after the integration in various combinations of the operation of generators and uh, renewable energy sources. The first bar chart shows the output voltages before the integration, and the second below bar chart shows the output voltage values after the integration. From by comparing these two bar charts, we can investigate the voltage level has a minor drop when the integrated with the renewable energy resources to supply the power. For example, when the renewable energy resources is in operation with the main generator, that is generator A, having the output rated voltage of 6600 volts. Uh, Before the integration, the voltage delivered was 7200 volts, as you can see on the chart above, which drops down to 6900 volts in the second figure shown. And this characteristics of integration follows for generator B and generator C. Thus, we can conclude that this integration, the renewable energy sources, can only be used to support the grid power to maintain the output level voltages, and cannot withstand alone to supply the power. This has to operate with one of the generator, either A, B, or C. Moreover, it has an advantage that the power generation of renewable energy resources is cost effective, with the cheaper maintenance for the energy producers, and delivering the same to the consumers at a low tariff rates. This generation also helps the consumers in saving a lot of money. Now, the ethical consideration. This research has no ethical issues and has approval from Leeds Beckett University, having the reference number of 126687. And finally, the references are shown on the screen. So this comes to an end of my presentation. A big thank you for listening to my. Thank you. Thank you so much.